Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be doing a brief introduction to circles. So let's go ahead and get started. So when we're talking about circles, I'm sure we've all seen these before. It looks something like this. And of course, when you're dealing with the circle, there are several characteristics we're going to talk about. First, we're going to talk about radius. Radius is defined as when you go from the center of the circle, so about right here, all the way across until it touches the edge of the circle there. So this right here would be an example of the radius right here. Normally, a lot of times it's drawn from going from the center to the right. I mean, it's not always like that, but you could easily draw it any other way you want. So it can go from down here to here. The point is that it's always going to be the same distance if you go from the middle of the circle until you touch the edge. That's how it is. It doesn't really matter. Now, when you go all the way across, let me just finish writing this out. So this is the radius right here. Excuse me. Radius. Now, when you go all the way across, it's called the diameter. So let me just draw you an example of that real quick. So diameter is kind of like this guy right here. And then you go all the way across. So the diameter is when you go all the way across from the middle, of course. You go through the middle point. So let's just say this is the middle point right here. About there. This is not beautiful and perfect, but you get the point. And this is the diameter. Diameter. That's kind of how it works out. And so these are characteristics of circles, as you will. And we will learn the equations behind these in a second. Probably not in this video, but in future videos, we will talk about the equations and how you determine these lengths, if you will. Now, if you want to just track the distance all the way around a circle, so let's just say I want to just track the distance here, going all the way around the circle like this. Again, this distance right here is called the circumference. So circumference, it's the distance around the circle. You can kind of think of it as the perimeter, if you will. Now, there are also other traits, other things that are connected with circles as well. So for example, let me just draw another circle here. Let's see what we got. Okay. Now, there's also something called a chord. A chord is when you have a line that touches 2 points inside the circle, but it doesn't go through the center necessarily. Now, if it goes through the center, it's called the diameter. But an example of a chord, if I had to give you guys one example, will be something like this. So let's just say, I changed the color of my circle. It doesn't matter. Let's see here. I just go from here to here. This would be an example of a chord. It's touching 2 points on the circle, but it's inside the circle, but it's not necessarily going through the center. If it goes through the center, now it's called the diameter. But if it's off to the side like that, it's called a chord. So this is a chord right here. All right, that's it. Now a tangent is when it only touches on one part, and they're always on the outside. They touch on one point. And so an example of a tangent would be if I had to go back to this circle right here, and I just, that's too ugly. I just barely touch it like that. This is a tangent. It touches the circle on one point only, as you can see right there. Now, a secant, if I just give myself a little bit more space here, a secant is kind of as follows. So draw a nice big circle here like that. Okay. So a secant, let's see here, is when you have the following. A secant is when it goes through and it touches on 2 points. So it's kind of like a chord that extends all the way through the circle, if you will. It intersects at 2 points and it goes through the circle. It doesn't stay inside the circle like a chord does, but it goes through and it touches on 2 points. So this is a secant right here. Like so. We talked about tangent. Now we can also talk about something called a sector. A sector is kind of like when you have a piece of a circle, if you will. That's kind of how it is. A piece of a circle. And a sector is measured in degrees. So for example, if I were to just take a piece of a circle, this is clearly a 90-degree angle right here, and this is just a little piece of the circle. So I kind of curve it like that. This would be a sector. and this particular sector is 90 degrees. Now, if I were to measure the outside edge of this, what do you call it? Like the circumference of this part, this little area right here, we call this an arc. So that little green area is called the arc when you measure that. That's kind of how that works. Now, a few more things that we need to talk about before we conclude this particular video is going to be as follows. So we have these ideals called a central angle. Now, a central angle is another ideal that you will commonly find and encounter. And it's basically when you have a circle. So I just draw me a nice big circle like that. All right. Now, what we're going to do here is we're going to draw a angle. So we're going to start from the middle. And then we go like so. And then we go up here like this. And then, of course, we're going to label this. So this is A, this is going to be C, and then B is going to be what we call my central angle because it's in the middle. And so this distance here, I'm going to make this a slightly different color here. This distance from here to here is kind of called the minor arc, if you will. So this is the minor arc. And then everything else, the distance from here on the other side, let's see here, I'll give you a different color. This distance all the way over here, going all the way across like this. This is the major arc. Major because it's bigger, not that deep. Major arc, like so. And so one thing that we can learn from this is that when you look at the measure of ABC, so I'm just going to write this down here below. The measure of angle ABC, so that's this guy right here, is going to equal the measure of the arc of AC. And that little rainbow above that is for the arc. And that's how that works. So this is something else where we're not going to talk about the application of it just yet. But I just want to try to lay down some terms as we continue. Now, there's one more piece of information that I want to talk about, and that is inscribed angles. This is also something you will commonly see. So let me go ahead and define this for you real quick, and then we'll be done. So an inscribed angle, just go down like this. All right, so an inscribed angle is essentially, you're going to have we're going to put a triangle inside this one. So again, it's not going to be the most beautiful triangle, but we're going to just try to do, that's too ugly. How about this? Okay, like that. And then we're going to go like this. And then we're going to go down like this. Now, this is not drawn to scale, obviously, but that's how it is. And so inside this triangle, it's going to be an equilateral triangle. So each side is going to be worth 60 degrees. So I'm just going to go ahead and label these like so. They're all the same. And so 60 degrees. 60 degrees, 60 degrees. So this is inscribed because the triangle is inside the circle. That's what's happening here. And so to make this as simple as possible, an inscribed angle is half of the intercepted arc. So what does that mean? Let me just draw this out for you. So if you look at, I forgot to label these, sorry about that. So this is angle D, or excuse me, this is point D. This is point F right here, and this is point E. Now, this makes more sense when you actually look at it. So the measure of DFE, which in this situation is going to be 60 degrees, is going to be, when you multiply this by 2, you're going to get the length of DE. That's how it works. So an inscribed angle is half of the intercepted arc. That's kind of what's happening here. So this 60 degrees right here, that means from here to here is 120 degrees. That's what's happening. That's the measure of this particular area right here. That's what's going on. And this is something, again, that we explore much more as we go through the various videos here. Now, I think I forgot to put the arc sign here. I think that's what I forgot to put right here. So put the little arc sign there. And that's kind of how that's supposed to be. So let's see if we can conclude this video and see what we learned. So in this particular video, we talked about, I don't need the inscribed thing, I forgot that. In this particular video, we talked about many of the characteristics or traits of circles. We talked about circumference, tangent, chord, as you can see the examples right here. Then we moved on and we talked about secant and sector and also arc. And then from there we talked about major and minor arc, and we also talked, major and minor arc as they relate to the central angle. And then lastly, we concluded the video by talking about inscribed angles. And so essentially, what we learned here is that inscribed means inside the circle, if you will, in this particular situation, because the circle is what we're dealing with. And that if you look at the measure of one of the angles inside the triangle and you multiply by 2, you'll get that measure of the other inscribed angle if you intercept, the intercepted arc. I'm sorry about that, So my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.